Allow me to recount a story that sounds so fantastic it seems like sci-fi. NASA has shut down a quantum computer after something insane occurred. In a world where innovation is continually redefining the limits of what is possible, we are on the edge of a new revolution that could bring incredible advances to humanity. However, quantum computers also present a danger that is hard to measure, especially when combined with artificial intelligence. Will machines soon take control of everything, or will this technology only bring us benefits? Billionaire visionary Elon Musk views the combination of quantum computers and artificial intelligence as a huge opportunity for humanity. Quantum computers can not only bring us incredible technological advances, but also improve all areas of our lives and find solutions to previously out-of-reach problems. With the ability to perform calculations at a speed and complexity far beyond traditional computers, quantum computers could drastically change everything from cryptography to drug discovery. But with this immense power come significant challenges and ethical questions. One of the most fascinating yet concerning aspects of quantum computers is their potential to break existing encryption systems. These systems form the backbone of all our digital security, protecting everything from online banking to government secrets. With the power of quantum computers, encryption methods like Shor's algorithm, which can factorize large numbers quickly, could be easily broken. This could threaten the security of confidential information and the stability of our entire world. If this technology falls into the wrong hands, we could face cyber warfare and chaotic scenarios across the globe. What exactly is a quantum computer? Imagine a typical computer that uses small parts called bits for its computations. These bits are like tiny switches that can either be on, representing a 1, or off, representing a 0. With these on and off switches, the computer performs all sorts of calculations. A quantum computer, however, uses something called qubits, which are also like small switches, but they can do something significant. They can be partly on and partly off at the same time, existing in a superposition of both states. This makes quantum computers exponentially more powerful than normal computers. However, qubits are extremely sensitive and require cold and absolute quiet to achieve optimal computing performance. This is why quantum computers look very different from typical computers or PCs. While the quantum computer itself is small, the cooling and buffering systems are quite complex. With their many tubes, the first quantum computers appear quite strange. The term quantum in quantum computing comes from quantum mechanics in physics. Quanta are particles of light and even smaller building blocks of matter, like atoms. Quantum mechanics teaches us that these quanta sometimes behave like waves, that they can exist in multiple places simultaneously, and that they only become particles when measured or observed. This concept might sound crazy, but it's precisely this reality that enables quantum computers to calculate far faster than traditional computers. The idea for quantum computers originated with scientists exploring these strange properties of quanta. One of the pioneers in this field was Richard Feynman, a brilliant scientist whose influence can be traced back to a speech he gave in 1981 at a physics conference in Snowbird, Utah. In his speech, titled Simulating Physics with Computers, he introduced the idea that physical processes could be simulated more efficiently with computers based on the principles of quantum mechanics than with classical computers. Feynman argued that the complexity of quantum phenomena was so great that regular computers could not simulate them efficiently. He suggested that a computer using quantum properties, a quantum computer, could achieve this task far more effectively. This idea was revolutionary because quanta, as the building blocks of our universe, are very likely something like metaphysical information carriers. This means that a quantum computer could theoretically access the blueprint of the universe. Quantum phenomena like entanglement and superposition could be used not only to solve practical problems, but also to potentially provide us with access to information we don't yet have. A quantum computer could help solve existing problems in astrophysics, reveal the origins of the universe, or even assist in finding new medicines or predicting the weather with high certainty. It's like having a super-intelligent visionary helping us solve the toughest puzzles. An emergency at NASA, imagine how quantum computers are revolutionizing space travel. With their extraordinary computing power, quantum computers could perform complex simulations of space missions, accurately replicate the dynamics of galaxies, or design new materials for spacecraft that can endure extreme conditions in space. They could also help analyze massive amounts of data from telescopes and space probes. Combined with artificial intelligence, a quantum computer could independently explore space, like a super scientist, and provide us with all the data we could possibly need. But with this incredible technology come risks. If NASA were to use a quantum computer, spies or saboteurs with their own quantum computers could access NASA's systems, steal or manipulate confidential information about space missions, advanced technologies, or national security data. This wouldn't just endanger NASA's missions, but also the security of national and international space programs. Terrorists could take control of entire rockets. Tampering with data or control systems of rockets and satellites could lead to glitches or even the loss of extremely valuable objects, such as the James Webb Space Telescope. Quantum computer systems at NASA and other major agencies would need to be constantly monitored and highly secured to prevent misuse. Despite these concerns, quantum computing technology also offers remarkable opportunities, especially in drug research. Quantum computers could help examine complex molecular structures and develop new drugs faster than ever before. The challenge is to harness the benefits of quantum computing while minimizing the risks. Scientists and researchers worldwide are working on new cryptographic methods known as post-quantum cryptography. These systems are designed to protect us from potential threats posed by quantum computers. Post-quantum cryptography is an encryption technique that cannot be broken even by the most powerful quantum computers. Where a threat emerges, a defense system is developed in parallel. We also don't fully know what lies ahead for us due to the increasingly interconnected world and the internet. Both technologies have evolved and become standard, and our world has generally benefited from these advancements. Something similar will likely happen with quantum computers and encryption technology. We are continually forced to redefine the boundaries of security in the digital world, and we will do so. Ultimately, quantum computers, with their unparalleled processing power, will also help us create more security. A powerful combination: quantum computers and artificial intelligence. Consider, for a moment, the possibility of combining these supercomputers with artificial intelligence. Quantum computers could play a critical role in verifying the accuracy of information generated by AI systems, such as chatbots. In the future, quantum computers, with their ability to perform complex calculations at astounding speeds, could theoretically help perfect the reliability and precision of AI-driven responses. This would be especially important in areas where accuracy is crucial, such as medicine, finance, or law. But there is also a darker side to these two technologies. The combination of quantum computing and AI could bring new dangers and opportunities for misuse that are currently hard to predict. One concerning example is deepfakes, which are false recreations of image and video material made by AI. With the processing power of quantum computers, deepfakes could become even more convincing and difficult to detect. We could suddenly find ourselves living in a reality where fake videos and news are nearly indistinguishable from the truth, leading to serious consequences. Imagine a video that appears to show the President of the United States or another influential leader making an aggressive or provocative statement towards another country. This could be a severe insult to another head of state or even an incitement to war. Given the current global tensions, this could have devastating consequences. The video, fabricated with AI and quantum computing, could look real to the untrained eye. Social media and news channels could spread it, or hackers could infiltrate reputable news sites to disseminate it further. The reactions could be catastrophic: international unrest, stock market panic, political crises, and even military responses, all before the deception could be exposed, potentially saving the world from chaos. Who would have thought that quantum computers could one day play a key role in the fight against climate change? These ultra-powerful computers could help us tackle some of the most pressing environmental issues of our time. Imagine quantum computers being used to simulate incredibly detailed climate models, predicting the effects of various environmental factors on the climate with an accuracy never achievable with conventional computers. They could help us understand weather phenomena, like El Niño, more precisely, or calculate the long-term effects of greenhouse gas emissions on global warming. Future generations of these machines might also help us find solutions to environmental challenges. Are there ways to influence the climate? What are the ultimate factors? This should not be a problem for a quantum computer with the right program. Quantum computers could help us develop new eco-friendly technologies. For example, they could drive the development of more efficient solar cells or the discovery of new methods for CO2 capture and storage. With their processing power, quantum computers could optimize energy distribution grids to make renewable energy sources like wind and solar more efficient. The possibilities are nearly limitless. It is already clear that these computers are coming, security concerns or not. We need this technology. The advancement of quantum computers has already made significant progress in recent years. Some of the best examples come from companies like IBM, Google, and Rigetti. However, these quantum computers are still far from becoming everyday machines. They are mainly found in research laboratories and are not yet suitable for general use due to their size and complexity. For regular users, like you and me, the extremely expensive quantum computers will likely be available through cloud systems eventually. You simply buy or rent access to one of these supercomputers, and quantum computing will be available in your home. Need more exciting and up-to-date information? Then subscribe now.